Alright, in today's video we're going to practice some simple statistics that are used in grade 9 science class. We're given here a table of densities that were measured for a sugar solution, measured in grams per milliliter. We have 9 different results, and we're asked to find the following basic statistics. So we want to calculate the range of the results, the mean, the median, the mode, and at the end we'll also look at the true value for the density, and we'll calculate the error and the percent error based on the mean. All right, so first of all, the range. The range is simply how spread out the data is. If you're not sure about any of these terms, you might want to take some notes for yourself as we go. So the range is a measure of how spread out the data is. So to calculate the range, all we're going to do is take the largest value from the numbers that we have in the table and subtract the smallest value. So the range is the largest value minus the smallest value. So in these numbers, the largest value was 1.35, the largest measured density, and we subtract the smallest density value. So looking at these numbers, the smallest density appears to be 1.24. So subtracting the largest minus the smallest gives you the range, how spread out the numbers are. There are other, even better ways to find how spread out the data is, but this is a very simple way to do it. Now you remember when subtracting or adding with measurements like this, we're going to write the answer based on the number of decimal places. So we have 2 decimal places and 2 decimal places. We're going to keep 2 decimal places in the range. So we get 0.11 grams per milliliter is the range. The units are the same as the units of the density up above. Next, we want to calculate the mean. Now, the mean is what most people mean when they say average. But technically, an average could be either the mean, the median, or the mode. Those are all measures of what's called central tendency, or average. But in everyday language, when you say average, usually you're referring to the mean. So to get the average, in this case, the mean, we're going to simply add up all 9 numbers and then divide by the number of numbers in the table. So we'll divide by 9. I'm not going to show my work for this, I'm going to just do this. 1.30 plus 1.35 plus, I'll also put dot, 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 meaning I'm going to continue, and I'll put the last one plus 1.33. So that's showing that I'm adding up all 9 values from the table, and we divide by 9 the number of numbers in the table. So let's do that on our calculator. 1.30, 1.35, I'm adding these together. 1.27, 1.27, 1.33, 1.28, 1.24, 1.27, and 1.33. So I get a total of 11.64. Remember, when adding together measurements like this, again, we keep the number of decimal places in the answer as the same as the number that had the fewest decimal places in the measurements being added. In this case, all the measurements had 2 decimal places, so we're keeping 2 decimal places there. And we divide by 9. So 11.64 divided by 9, and I get a mean value of 1.29 grams per milliliter. All right, so there's the range, there's the mean. Now let's calculate the median. The median is another way of expressing an average. So this time what we need to do is we need to look up at the 9 values, and we need to pick the middle value. That's what the median is. It's the middle value. So now before you can find the median, you need to start by putting these 9 numbers in order from smallest to largest, or largest to smallest. I'll go from smallest to largest. So my smallest result up above was 1.24. Then we have a 1.27. Looks like we have 1, 2, 3 of those. 1.27, 1.27, 1.27, we have a 1.28, and then we go up to let's see, let's cross them out so I don't forget which ones I've used. So 1.24, 1.27s, 1.28, I've got a 1.30, I've got a 1.33, two of those. And finally, I've got a 1.35, the largest value. So now you notice, just double check, 1, 2, 3, 4, 5, 6, 7, those are my 9 values. So the middle value is simply in a group of 9 values. The middle value would be the 5th value. So this value here, there's 4 to the left of it, there's 4 to the right of it. That's the median value. So 1.28 grams per milliliter. Now, in this case, with an odd number of values, it was easy to pick the middle one. If you had an even number, so suppose there was one more result, we had 10 results instead of 9, then there would be 2 values that are in the middle, right? There'd be 2 of them that would be in the middle. So what we do then is we take those 2 middle ones and we find the mean of those. So for example, if we add on, just for the sake of argument, let me use a different color, suppose there was another value and it was actually 1.37. We'll make it even larger than the last one. So now I have 10 values. So in this situation with 10 values, the 1.28 and the 1.30 would have been considered the middle. And so what you would then do to find the median is you would take the average of those. So 1.28, the mean rather of those, plus 1.30, divide by 2. And you'd get 1.29 in that case, grams per milliliter. All right, so when there's an odd number of values, the median is very simple. It's the middle one after you have arranged them from smallest to biggest. If you have an even number of values, then you'll have 2 middle values. You take the mean of those 2 middle values. Now the last average that we're going to calculate here is the mode. The mode is the most common value. It's the one that you see most often among your measurements. You don't always have a mode. Maybe all 9 values were unique. There's no value that repeats. Sometimes you'll have more than one mode. Maybe there's a value which is 3 times in one situation and another value 3 times also. So you have 2 of them that are equally showing up in your data table. Then you'd have 2 modes for that. In this particular set of data, if we look carefully, we can see that there is the number 1.27 over here, 1.27, 1.27. It appeared 3 times. It's the most common value. So the mode, very simply, the most common value in this case is 1.27 grams per milliliter. There's no work to show for that. Now suppose you were given a true value. So the actual density of that sugar solution. Suppose it was actually 1.24 grams per milliliter. Okay? Actually, I'm going to change that. I'm going to make it a bit different. Suppose instead of 1.24, we have an actual density of 1.34 grams per milliliter. All right, so we're given, this is the actual, the true density of that sugar solution. Let's calculate the error and the percent error. And we'll do that using the mean. Okay, I'm just picking that value. So what is the error in the mean, or the percent error in the mean, where we had 1.29 as the mean, if the actual density was 1.34. So to get the error, you remember the formula for that is to take your experimental value and subtract the true value. The experimental value is the value you got. So for us, our actual mean, the one that we calculated, was 1.29, but the true value is 1.34. So we can see that our mean is actually too low, and that's going to mean that this error will be a negative number. If our mean was too high, then we would get a positive number. So the experimental mean was 1.29. Subtract the true value, 1.34. And again, watching significant digits, we'll keep 2 decimal places. We get 0.05 grams per milliliter is our error, right? So that's the error in the mean. Now the percent error is the error, the thing that we just calculated, divided by the true value times 100. So we'll take our error that we just found, whoops, this should have been a negative 0.05, my mistake, sorry. So negative 0.05 grams per milliliter, negative again because our result was too low, and we subtract, so we divide, it's Sunday morning, forgive me, we divide by the true value, 1.34, and we times by 100. Notice the units will cancel out here. The percent error does not have any units other than percent. So negative 0.05 divided by 1.34 times 100. I get negative, I'm going to keep only one digit because the error had only one digit. So I get negative, the calculator says 3.73. I'll call that negative 4% error. Okay, so watch your significant digits rules. Dividing like that, we look at the lowest number of significant digits. 0.05 has one significant digit. 1.34 has 3 significant digits. So I keep only one significant digit in the answer. That's the rule for multiplying or dividing with measurements. All right, so in this little quick video, we've reviewed basic statistics, how to calculate the range, the largest number in the set of numbers, subtracting the smallest number. The mean is what we normally think of as average. You add up all your numbers and divide by the number of numbers. The median, you rank your numbers from smallest to largest and you pick the middle value. That's easy in an odd set of numbers. In an even set of numbers, you'll have 2 middle values. In that case, you would take the mean of those 2 middle values. The mode is the most common value in the set of numbers. There isn't always going to be a mode. If they were all unique, there would not be a mode. And sometimes there can be more than one mode. In this case, the mode was 1.27. If you have a true value, like we did here, we were given the actual density, then you can calculate an error. We did the error in the mean, but you could have done the error with the median. You could have done the error with the mode. We just did it with the mean here. You take the experimental value, your value, and subtract the true value. It'll be negative when your value is lower. It'll be positive when your value is bigger. And finally, percent error, you take that error and divide by the true value and multiply by 100. Don't forget to keep the positive or negative symbol in your percent error.